Hello and welcome to another edition of Hydrolysis Reactions of Carboxylic Acid Derivatives. That was a mouthful. Okay, in this video we're going to look at the acid hydrolysis of amides. Okay, you may notice Professor Pink Penelope's still not here. She's still on leave due to a concussion she had a couple lectures ago. So we've got Chicky Chick subbing in on this lecture. The lights are a little bright in here, so hence the sunglasses. And you know, this is kind of a late night or late evening version of organic chemistry lectures, about the time you'd watch a movie. So I brought some to celebrate. I brought some popcorn here. I've always thought watching an organic mechanism, it's like watching a good sci-fi thriller. You never know what's around the corner. So let's find out what's around the corner with this amide. All right. So, what we're going to do is we're going to take this amide, the same amide we use in the base hydrolysis of an amide, just so I can kind of show you how the mechanism will be different. And remember, we're going to use strongly acidic or strongly basic conditions. In this case, we're going to use 6 molar HCl, okay, which is fairly strong, okay. And the solvent is water. Ooh, H2O and not H3O. Okay, HCl and water. And when we're done hydrolyzing this amide, we will have a carboxylic acid plus an amine salt. Okay, so there's the ammonium ion and then Cl minus. Okay, that makes it a salt. Okay, so that's where we're going to head with our mechanism. All right, this mechanism is going to have the same mechanistic steps as the acid hydrolysis of esters. Okay, and so watch for those steps. Okay. All right, so the first thing that's going to happen, okay, this is a nucleophilic acyl substitution reaction. Because we're using acidic conditions, we're going to start by making this a better electrophile, and we're going to use that with our strong acid here, and we're going to do a proton transfer, PT. That makes a protonated carbonyl. Okay, now it's a good electrophile. So weak nucleophiles like water can attack it. And that's what's going to happen next. Water's going to come in here. It's actually not that bright in here. I just wanted to have a chicken that had sunglasses on. So, all right. Nucleophilic addition. Although the glare might make you think it's really right here. Okay. All right. So nucleophilic addition. Focus. I gotta focus here. All right. All right, that's what happens after a nucleophilic addition. All right, we're almost to our intermediate, which is a neutral compound. So we need to do a proton transfer. What did I say? We were using water and HCl. Okay, so we've got a fair amount of water floating around. It's always good to do proton transfers with things that are actually in the reaction mixture. Okay, that's preferable, recommended, advised. Okay, and this is our tetrahedral intermediate. We call it tetrahedral because the geometry at this carbon is tetrahedral. It's an sp3 hybridized carbon. Okay, And it's always good to remember at this point what's going on. We're doing a hydrolysis of an amide, so we're going to break this C nitrogen bond. So we need to turn this into a good leaving group, and that's what I'm going to do now. Okay, so I need some more space to do that. Up to this point, we've done a proton transfer, nucleophilic addition, proton transfer. Okay. We're going to turn this into a good leaving group by doing another proton transfer. Okay. Okay, that gets us up here, proton transfer. H. Where was I? Okay, so that's a proton transfer. And then we're going to have that leaving group leave via a nucleophile elimination step. Okay, and that's going to get me a protonated carboxylic acid plus methylamine okay. Got a Bronsted base sitting there. It's hungry for some protons, so it's going to do it. I'm going to finish up with a proton transfer. I'm going to erase this, and that's ultimately going to get me acetic acid in this case, plus this protonated amine. Okay, and we had some HCl or some chloride ion that we generated actually in this step. It's been hanging around with us. Okay, and so it's here too. It's acting as a counterion. So there's my amine salt. All right, so carboxylic acid and amine salt is the final product of this acid hydrolysis of amides. And just to recap, we've got six elementary mechanistic steps. It's kind of a proton transfer sandwich, double-decker proton transfer sandwich. Proton transfer and nucleophilic addition, proton transfer, and nucleophile elimination, proton transfer. All right, and so that concludes our hydrolysis of amides under acidic conditions. And I think in the next video, we'll probably be hydrolyzing a nitrile. All right, thanks for watching.